Voyager's Final Whisper. Secrets from the edge of our solar system, humanity's most distant ambassadors. In 1977, NASA launched what would become the most ambitious and far-reaching space mission in human history. Two spacecraft, Voyager 1 and Voyager 2, began their journey from Cape Canaveral. Their goal was to explore the outer planets of our solar system, but they would ultimately go further than anyone dared dream. Over 4 decades later, these twin explorers are still transmitting data from the farthest reaches of the solar system, revealing secrets about planets, magnetic fields, radiation, plasma, and the very boundary between our solar neighborhood and the vast unknown of interstellar space. As the final chapter of the Voyager mission approaches, let's revisit their remarkable journey, the shocking discoveries they made at the edge of the solar system, and what we might learn from the last signals these aging probes send, the rare planetary alignment and launch. A once-in-175-year planetary alignment in the late 1970s offered a unique opportunity. Jupiter, Saturn, Uranus, and Neptune were lined up in such a way that a single spacecraft could use gravity-assist maneuvers to visit all 4 planets. NASA seized the moment. Voyager 2 was launched first on August 20th, 1977. Voyager 1 followed 2 weeks later on September 5th. Despite being launched later, Voyager 1 took a faster trajectory and overtook its twin. It soon became the first to explore Jupiter and Saturn. Only 13 days after launch, Voyager 1 captured a historic image of Earth and the Moon from over 7 million miles away. It was the start of a breathtaking journey through the solar system, a mission originally meant to last just 4 years. Triumphs at Jupiter and Saturn. In 1979, both Voyagers reached Jupiter. They discovered its faint ring system, 3 new moons, and captured close-up images of the planet's major satellites. Voyager 1 revealed that Ganymede, not Titan, was the largest moon in the solar system. Perhaps most famously, the probes captured detailed views of Europa, showing its icy surface covered with deep cracks. This led to the hypothesis of a subsurface ocean, sparking ongoing speculation about the potential for life beneath its frozen crust. Voyager also gave us the first up-close look at Jupiter's Great Red Spot, a centuries-old storm larger than Earth. Using Jupiter's massive gravity, the spacecraft slingshotted towards Saturn. In 1980 and 1981, both probes flew past Saturn, delivering groundbreaking data. Voyager 1 focused on a close flyby of Titan, sacrificing its ability to continue to Uranus and Neptune. Voyager 2 continued onward. The Saturn flybys revealed the complexity of its rings, consisting of hundreds of narrow, intricate bands and 4 new moons. Titan's thick atmosphere also became a subject of intense scientific curiosity. Into the ice giants, Voyager 2 reached Uranus in 1986. Unlike Jupiter and Saturn, Uranus had a colder, more unusual makeup. Below its hydrogen-rich atmosphere was a deep ocean of water, ammonia, and methane, making it the first identified ice giant. Voyager 2 discovered Uranus to be the coldest planet, despite being closer to the Sun than Neptune. It also found that Uranus rotated on its side and had a tilted magnetic field, baffling scientists. Then in 1989, Voyager 2 became the only spacecraft to ever visit Neptune. The images captured revealed an unexpectedly vivid blue planet, although later data corrected that to a teal hue. It observed Neptune's Great Dark Spot, fast-moving winds, and Triton, a moon with geysers and retrograde orbit. With these encounters, Voyager 2 completed its grand tour of the outer planets, having visited all 4 gas and ice giants. Voyager 1, meanwhile, had moved on to a new frontier, interstellar space, a pale blue dot, and the journey beyond. In 1990, before shutting off its cameras, Voyager 1 turned back to take one last picture. From 3.7 billion miles away, it snapped Earth as a tiny, pale blue dot, just 0.12 pixels in size. This became one of the most iconic images in space history, immortalized by Carl Sagan. For years afterward, the Voyagers drifted quietly in the darkness, their instruments collecting data about magnetic fields, plasma waves, and cosmic rays. Then in August 2012, something extraordinary happened. Voyager 1 detected a sharp drop in solar particles and a rise in galactic radiation. This marked its entry into interstellar space, the first human-made object to do so. Voyager 2 crossed the same boundary in November 2018, confirming the results. What lies beyond the heliopause? The Voyagers passed beyond the heliopause, the boundary where the sun's influence ends and the interstellar medium begins. Before Voyager, scientists assumed the solar wind would gradually fade with distance. Instead, the data revealed a sharp cutoff. Outside this boundary lies a different realm, a place where cosmic rays dominate, the magnetic field strengthens, and colder, denser plasma surrounds the solar system. Surprisingly, the solar wind doesn't just fade, it redirects, flowing along the edge of the heliopause like a current around a rock. Interstellar particles flow from the other direction, forming a dynamic barrier between solar and galactic environments. The shape of the heliosphere also proved unexpected. It resembles a squash sphere with a long trailing tail, not the smooth bubble once imagined. These discoveries shattered previous models and opened new questions about stellar interactions and cosmic boundaries, unexplained anomalies and density surges. As Voyager 2 moved farther, it found something bizarre. The density of space beyond the heliopause increases, contradicting earlier beliefs. At certain points, particle density was 10 times higher than predicted. Why this happens is still unknown. Some theorize it's due to collisions between the solar and interstellar plasma, creating a particle traffic jam. Others suspect fluctuating magnetic fields or hidden energy sources. Meanwhile, Voyager 1 recorded unusual temperature drops, plasma waves, and inexplicable changes in the interstellar medium. The further the probes drifted, the stranger the environment became, the mysterious signal and communication failures. In 2022, Voyager 1 began sending back cryptic data, random strings of binary and repeating numbers. Scientists feared they had lost control of the probe. Then in late 2023, Voyager 1 went completely silent. After months of analysis, NASA determined the cause: a memory failure in one of the flight data subsystems. The fix? Rerouting critical code to a different part of the onboard computer, a risky procedure considering it takes 45 hours to get a round-trip signal. Amazingly, communication was re-established in April 2024. Voyager 1 was alive again. These breakdowns are reminders that the probes, now 47 years old, are operating decades beyond their expected lifespan. The local bubble and galactic structure. Voyager's data also help confirm that our solar system floats in a low-density void known as the local bubble. Created by supernova explosions millions of years ago, this bubble is nearly 1,000 light-years across. Thanks to this bubble, Earth is protected from dense interstellar clouds and extreme radiation. It may also explain why the night sky is so clear, allowing astronomers to observe deep space with remarkable clarity. The Sun appears to have drifted into the center of this bubble about 5 million years ago, possibly influencing Earth's environment and even the rise of complex life. Legacy, limits, and humanity's future in space. NASA expects the Voyagers to continue operating until around 2025. After that, their power will fade, instruments will shut down, and Earth will fall silent to their signals. But even after contact is lost, the probes will drift silently through the galaxy. Voyager 1 will pass near the star AC plus 79, 3888 in 38,000 years. Voyager 2 will approach Ross 248 in about 40,000 years. They may outlive humanity, or perhaps one day another civilization will intercept one, reboot it, and learn about the distant planet we call home. Until then, Voyager remains a reminder of what science can achieve. A whisper from Earth, still echoing in the cold dark. The Voyager mission changed how we see our solar system, our place in the universe, and our capacity to explore the unknown. These tiny spacecraft, launched with 1970s technology and fueled by ambition, gave humanity a view of the cosmos it had never seen before. As they prepare to go silent, their journey is far from over. They will continue onward, carrying our message, bearing witness to the stars. If this story inspired you, please like, comment, and subscribe for more incredible stories of exploration. Turn on notifications so you don't miss our next journey through the cosmos. And remember, the universe is vast, mysterious, and waiting. Keep exploring.